Good morning. Thank you. My name is SIMCHA. And I'm here to talk to you today about what we do in the world of agriculture. You will see, because there are a lot of military people here, you will see a lot of similarities to the military world. I've served many years in the IDF, and 4 years ago when I retired, I have taken the same methods and techniques into the world of agriculture, and I will give you a few examples of this thing. At the end of the day, it's about data. But the challenge here is a bit different than the world of defense. It's global. It covers almost the entire planet where there's water, and it's very challenging when it comes to information, to data. So if you don't know the world of agriculture today, we are in what is known as the fourth revolution of the agriculture after pesticides, chemical pesticides, and some sensoring and some precision agriculture. We are still at a point where we are at the limit of our ability to grow food in a world where we need a lot more food grown. About in 20, 30 years from now, we'll have 3 billion more people to feed, and we are already at the limit. We grow 7 billion dunams of field growth, corn, wheat, rice. They're already stuck for 10 years. We're unable to break that ceiling and grow more. So it brings us to worlds of ag tech and food tech in order to create more food, grow more food using less. In Israel, we have hundreds of ag tech companies. Amongst those, quite many are using drones and sensoring. Remote sensoring. We are not a drone company. We are just making use of that. We have different, very, very small drones that we are using. The smaller, the better. And we are empowering those people who have these little toys to make them into an autonomous system for remote sensoring. So this is a whole story. We are not there to do it. It's the user who does that. We do not fly those. So the Israeli agriculture grows about 2 tons per 10 hectares in ratio to the world, to the rest of the world. So in the south, they grow about 10 tons. In the rest of the world, they do 5. They work in this. They use the same resources and the same effort, but they don't have a plant doctor. And in Israel, for 70 years now, there's a startup, inspectors, who just walk in the fields, and they are the intelligence of the field. So the great majority of the world are stuck in World War II and have no idea what happens in the field, and they are just bombing everything. 10 B-20 just drop a lot of bombs. You might hit a building, but now they just do it more and more. They're creating bigger cocktails with more chemicals, more variety of chemicals. Ever since World War II, we use more chemicals on our food, but we do not get the desired effect because there's no connection between the chemicals and the problems in the field. So we also have a problem with sustainability. Each liter of water that we use is liter of chemicals in our food. So the story is about making use of these technologies, this amazing technology of the drone, and taking photographs in amazing high resolution, and I will show a demonstration. And we're using AI actually in order to examine endless amounts of data. We're using about millions and millions of leaves per day. No people can, do that amount of collect that amount of data. So we are using this as a common denominator to collect the data for the agricultures. It will take, stills photos, but 3 million of those every year. It will be doubled. I meet so many agricultures and farmers in the world that are using those drones, and if they don't have it, $1,000, $999, and they can get the toy and collect data about thousands and thousands of dunams, hectares per year. Most agricultures in the world do not have 10,000 hectares. They have, a lot less than that, about 2,000, 3,000. So this can cover huge spaces. And you look at this, and it gives them the understandings and the insights that they need. So we observe everything that you can visually see. So you see examples here. You see it at the left, a disease, right? It's a 0.5 millimeter of pixel. It's like eye vision. And I fly this drone at 2 meters above, and it can show you the leaves. Most pests don't live on the leaves. They live under the leaves because of the sun. So we just actively turn over the leaves, and the camera, thanks to Bender today, is taking pictures of this in this high resolution. It's not a building. Think about it, a bush. This drone is over the bush. You see the entire bush just flying away, right? And yet the picture is this very, very sharp resolution picture. You see also other options to the right side. You want to know how many plants have grown per hectare. So they just come out to the field and they count them. I don't know when you visited a field lately, but a field in the size of this room can hold 1 million plants. It's not even statistical. They just look at 2 spots and they count them. We have the ability, using stand count, taking photos. They've never seen it's surprising to them because they've never seen the field from bird's eye view. And once I have stand count, I know that I have a 700 instead of 1,000. I know there's a problem. So the complexity is in the data because it's biological data. When you see the certain disease here, to me they all look like different things, right? The same disease can have different expressions in the picture. The story is sort of data. In 2019, I paid my people to take pictures of tens of thousands of pictures using drones over potato fields in the Western Negev. Today, we take tens of thousands of pictures per week in over 20 countries of over 20 crop types. And we don't take any of those pictures that we take because they all work for us. Those users don't tell them. The more data I have of each crop, I can teach the system more and more actions in order to help the drone perform its work. So we are going through the cycles in the fields. Now, potatoes, okay, we'll go back to this field in 4 years. During these 4 years, we will grow different things. So there's a crop cycle that is different. So we look at the life cycle of this specific field from here and eternity, and we've been doing it for years now. So for some of the fields, we have quite a lot of info, and we are accompanying them from seeding to harvesting. But the main gatherer is the drone. A few years ago, it had a couple of minutes. Now it has 20 minutes airtime, and I can go through 500 dunams, 5,000 hectares. So it's not just cornfields or soy fields that you start in sunlight and don't get to the end of them at sundown. It's not these, but in most fields in the world, this is more than this number. So when I create more and more data of this kind in a certain place in Hula Valley or in Negev, Western Negev, even when I don't hold an Shlomi's field, I can tell you that in the Western Negev there is a certain disease right now, and it might affect commercially the chemical company in order to market the components that they use to reduce this problem. But like Iron Dome, for example, for all the different farmers in this area, when I tell them there's this certain disease around your area, they know how to take care of it, what materials to use. At the end of the day, this thing allows us globality. Unlike more local events, at the end of the day, we are riding on the fact that there are endless amounts of those in endless spots in the world, and it allows us. I've never been to South America, but I have an amazing amount of users in Brazil, and I've never even met them, maybe only through Zoom, and we allow them to do it in a very simple manner. The farmer, wherever in the world, is less excited with technology. They're not exactly the early adopters of technology. Simplicity, simplicity, simplicity. If it's not in the mobile, if it's not automatic, it's not for them. They just want to put it in the corner of the field, and you just take a photo at the beginning of the season, and that's it. It's automatically done. The drone goes back and forth by itself, and what we produce at the end is a report. They give a report, and presents a report to the farmer. In most parts of the world, we don't have these inspectors, so we are their inspector. The technology, the internet, the smartphone, the drone allows to bring this revolution to the farmers who usually don't see any normal doctors, not to mention their plant doctor. I talked about autophoto, and we've done that. for other things that I will show you. And we've presented it incidentally to the farmers in South America, and they were so excited. They've never seen their farm from bird's eye view, and you can see that the grow here is not covering everything equally because of problems of fertilizing and irrigation, and it allows them to move from something statistical to treating something. So right, it's not a missile into a window, but it's about let's spray just half the field, let's use more fertilizer to just a quarter of a field. So this is where we are at now. What we bring is almost to the level of one plant resolution, but unlike the military world where you need intelligence and you also need strike precision, we don't have that in agriculture. The first seeds of that I haven't yet seen in the exhibition, but I think we do have them, is the spray drones. Even a whole fleet of spray drones, they have very small amount of liters of chemicals, so it's not relevant to the fields in the world. But when you are able to precise where to strike or where to spray, you can close the circle, use not so many chemicals as on drone, and then move from statistical work to intelligence at the level of the plant to strike the level of the plant. What we've done is the orthophoto for this stand count report. It allows me to just one time do it, and then I know I can detect parts of the field where the growth is not done well, and then they can go and fertilize this specific point. So it brings them at the end of the season closer to where the Israeli farmer is. I'm not replacing the Israeli agronome or inspector, right, or farmer. We're just trying to bring the best we can to each plant and each farmer on earth. Canopy coverage. It's very interesting. We see how much green we see. Week 7 is supposed to look like that, and later it will change to cover everything. And it's very important for them because it shows them how strong the plant is, the crops is, and how much crop they're going to yield at the end of the season. They don't have it today. They have people just walking there and counting the number and trying to, understand how much they have all through the field. This allows them to see the entire field each week, and then they know what to do in order to increase growth. Okay, my time is limited, so I will stop soon. This is satellite. It's still half a meter of pixel. It's not much like the half millimeter of a pixel, but it is allowing us a multispectral view all over the Earth. The red parts, of course, are parts with areas of problem, especially of fertilizing and irrigation, which moves for me like I need a sortie of a drone to go and visit those specific points. Instead of using this little toy to huge fields, they will just use it as an indicator to go specifically to these places. Okay, I really like robotics. I love this. I love the autonomic systems. It's not really relevant to the agriculture world. There's not enough budget. And we've connected to American company. They use these little boxes holding this little toy drone, and it just goes to the cellular tower. And they have 40,000 cellular towers, and they ask them to put those on all their infrastructure, but it's done once a week. All the rest of the week, it is free to fly. They are in fields, right, and they give me internet, they give me electricity, and it covers thousands of dunams. The drone can just go in and out, and just upload my data for me. So this is Western Negev. Once you have enough data from drones, you can see different things of movement of the pests and the diseases in the area. This is a similar example in Washington, but a much bigger area, like 6-7 hours to go from north to south. You can see here to the right, we have actively turned the leaf using wind to take the eggs of the beetle that you see on the top. And the reason that the beetle is on top is because the air from the drone has moved and turned over those leaves. And this is the resolutions that we're using, and this will bring me to the end of my lecture. I said we want to go to intelligence at the level of a plant, per plant, which is what we want to do. We've done it for a whole season in a real field, hundreds of dunams with these beetles. Each little circle you see here is a picture where we've seen a beetle. Up till today, they've sprayed the entire field, tons of chemicals. Once the farmer saw this, he skipped spraying. So we skipped some chemicals, right? And And when he did spray, he only sprayed the edges of this field. And this is the future. Future is about lessening dramatically the use of chemicals. We are working globally. We work with huge companies that you know, such as Pepsi and such as Heinz. And I will only end here saying that we've just recently moved to the historical cowshed in Yeruham, kibbutz, and it says, I wrote from dairy farm to tech farm, our story in the industry of the UAV, UAS, whatever you want to call it today. We have a lot of ability to contribute to world agriculture, and this is how they are treating us. We get there to Terra Santa and they say, thank you very much, you're from the Holy Land, and they're very, very excited about the technology. So that's it from me. Thank you very much.